For at least the past 40 years, the far north of the planet has been warming much faster than the rest of the planet. In this video, I will show how much faster the Arctic is warming, and I will explain what is causing this rapid warming. The top figure gives us an indication of how much warmer the far northern part of the Earth had warmed by 2019 compared to the period from 1970 to 2000. Based on this kind of information, climate scientists reported that the Arctic was warming 2 to 3 times faster than the rest of the planet. However, these estimates were based on varying definitions of what constituted the Arctic region of the Earth. This uncertainty was removed when scientists looked specifically at the region above the Arctic Circle, 66.5 degrees north latitude. When they confined their attention to this well-defined region, they found that since 1980, the Arctic has been warming at about 4 times the rate of the rest of the planet, as is shown in the lower figure. The upper figure is from the recent preprint from the Finnish Meteorological Institute showing the excess warming in the Arctic. That is the region that's inside the dotted circles, and it's shown in degrees centigrade per decade. The actual observations are shown on the left, and beside that plot are 3 different attempts to reproduce the observations with climate models. The rapid warming of the Arctic region is being driven by 4 separate positive feedback effects that I will discuss in a moment. The lower figure from the Finnish preprint shows the geographical distribution of the strength of these 4 combined feedback effects, along with 3 attempts to model them. This is called the Arctic amplification, and the scale just shows the relative intensity of the amplification in various parts of the Arctic from these feedback effects. Clearly, in parts of the Arctic, these positive feedback effects are very strong. Much of the area of the Arctic is ocean, and the amount covered in sea ice varies during the year, reaching a minimum in the month of September. During the past decade, Arctic sea ice coverage has varied, but on average has been about 20 to 30% lower recently than when satellite measurements first began in 1979. The sea ice thickness also has been declining, and even more rapidly. Since it's white in color, ice reflects incoming solar radiation more effectively than the dark open ocean. Thus, when the area covered by sea ice declines, the ocean is heated a bit more by incoming sunshine. That's one positive feedback effect, because as the ocean heats up, it causes more ice to be melted. The second feedback effect is a less obvious one. It's called lapse rate feedback. Normally, the air temperature drops with distance above the surface. That drop is called the lapse rate, but under some weather conditions, atmospheric temperature inversions can take place, and the air temperature can be higher above the surface than near the surface. When that happens, the surface can't lose heat as effectively by upward convection of the air. These temperature inversions are fairly common in the Arctic, and they add to the positive feedback. Not all the Arctic is ocean, and much of the land area normally has been covered by permafrost. Permafrost is frozen ground that is full of decayed plant material. As the Arctic warms, the permafrost begins to melt, and bacteria in the ground can begin to consume the decayed plant material. This, in turn, releases both carbon dioxide and methane. Now, both of these are greenhouse gases, and they too can add to the warming of the region. This is the third feedback effect. Some of the land near the Arctic Circle, however, is covered with vegetation, and in recent years, large wildfires have burned in the far north. These wildfires release more carbon dioxide into the atmosphere, and that additional carbon dioxide adds to the warming of the Arctic region. The rapid warming that's taking place in the Arctic region has significant effects on the behavior of the jet stream in the northern hemisphere, and that in turn can lead to some extreme weather events at lower latitudes. I will be discussing those effects in a future video. If you haven't already done so, please subscribe to my YouTube channel to be notified when I post that video. Just click or tap on my picture in the circle below. Thanks for watching.